Good day everyone. For today's video, we will discuss the chapter 4, which is the relative equilibrium. Without further ado, let's get started. In problem 213 by BSABE-A, an open tank 15-meter long is supported on a car moving on level track and uniformly accelerated from rest to 40 km per hour. The tank was filled with water to within 20 cm of its top when it was accelerated. Okay, 1. Let us compute the acceleration of the car. 2. Find the shortest time in which the acceleration may be accomplished without liquid spilling over the edge of the tank. Number 3. The height of water is 1 meter when the tank is at rest. Determine the total force acting on the bottom of the tank when the tank was accelerated if it has a width of 2 meters. So to further understand the problem, we have here the figure. It has a 5 meter distance. Okay, now let us proceed to our solution. So for our solution, first let us find the acceleration of the car. So the formula that we will be using is the horizontal motion, which is tan theta equals acceleration over gravity. So by substituting to the given solution, we have 0.20 meter over 5 meter is equals to 0.04. So now let us find the acceleration. So 0.04 multiplied to 9.81 meter per second squared, which is our gravity. So the acceleration will be 0.392 meter per second squared. So now we have found the value of the acceleration of the car, which is 0.392 meter per second squared. Let us proceed to the number 2. Let us find the shortest time in which the acceleration may be accomplished without liquid spilling over the edge. So V1 equals 0. V2 equals 40,000 meter per hour over 3,600. So let us divide the 40,000 meter per hour over 3,600. We have the value of V2, which is 11.11 meter per second. So let us proceed. Since we have now the value of V2, let us substitute the V2 by 11.11 meter per second. And since the value of V1 here is 0, so let us substitute V1 into 0. So 11.11 meter per second is equals to 0 plus the value of our acceleration, which is 0.392 meter per second squared, and we are now finding the time. So by multiplying this given, we will now have the value of time, which is 28.342 seconds. So let us proceed the question 3. Let us find the total force acting on the bottom of the tank if the width of the tank is 2 meter. So the formula that we will be using here is P1 equals unit weight W multiplied to height 1. So P1 equals 9.81 meter per second squared multiplied to height 1, which is 1.15 meter. So P1 will be 11.28 kilopascal. Okay, for our P2, the formula that we will be using is P2 equals unit weight of W multiplied to height 2. So, let us substitute the given values. For the unit weight, we have 9.81 meter per second squared. And for our H2, we have 0.85 meter. Thus, the value of our P2 will be 8.34 kilo Pascal. So, let us find now our force. So, we have F is equals to P1 plus P2 over 2 multiplied to A. So, let us substitute all the given. So, F is equals to our P1 which is 11.28 plus our P2 which is 8.34 kilopascal over 2. So, our F will be 196.2 kilonewton. So, that could be all. Thank you for listening.